Our entire solar system, every planet, every moon, every rock, every speck of dust we have ever named, is, compared to the rest of the universe, essentially nothing. A single grain, glowing faintly under an ordinary yellow star, sitting in an unremarkable corner of an average galaxy, in a universe so vast that no number we use in daily life comes anywhere close to describing it. And yet, if you were to draw an invisible sphere just 100 light-years wide around that grain, you would find thousands of stars packed inside it. Some so faint that no human eye has ever registered them across all of recorded history. Others burning so fiercely they can be seen from across entire galaxies. Between those stars drift frozen rocky worlds, planets smothered under thick poisonous atmospheres, and objects so strange we haven't invented the right words for them yet. A few of those worlds might hold life. A few might one day be a problem. And every bit of that, every planet, every dim light, every nameless object, is just a thin sliver of the Milky Way. 200 billion stars at minimum. Over 1 trillion planets by rough count. No civilization will ever visit all of it. But the stars closest to home, those we can actually study. And what we've learned about them recently, especially since 2024, would have sounded like complete fiction to any astronomer sitting at their desk in 2018. 6 light-years away, in a constellation called Ophiuchus, a small red star named Barnard's Star has been quietly moving across our sky faster than any other star we track. It's closing in on us at 68 miles per second. Fast forward 10,000 years, and it becomes our nearest neighbor. You still won't see it without a telescope. It's simply too dim, but it will be there, closer than any other star in the sky. For a full 100 years, astronomers kept announcing planets around Barnard's Star, and for a full 100 years, every single claim eventually collapsed. The most recent false alarm was 2021, a supposed super-Earth that turned out to be nothing more than the star's own magnetic activity masquerading as a gravitational tug. Then October 2024 arrived. The espresso spectrograph in Chile pulled out a real signal. A few months later, in early 2025, a completely independent instrument on a different mountain in Hawaii not only confirmed what Chile saw, it found 3 more alongside it. For planets, confirmed, around a star 6 light-years from home. None sit in the habitable zone. Scientists are 99% confident no Earth mass world is hiding there either. These 4 are smaller than Earth, each carrying somewhere between 19 and 34% of our planet's mass. But that's not the point. The point is that 2 separate teams, on 2 different continents, using 2 different instruments without coordinating their work, arrived at the exact same answer about a star 6 light-years away. That kind of certainty did not exist 10 years ago. The stars haven't changed. We got better at reading them. Turn around completely, and the view shifts to its absolute opposite. Sirius, the brightest star in the entire night sky, just 8.6 light-years from Earth. To the naked eye, it looks like a single cold white point of light near the constellation Orion on a winter night. Get close enough, and that single point splits in 2. Sirius A, the dominant star, is about twice the mass of our Sun, 70% wider, and pumping out 25 times more raw energy. Its surface burns close to 10,000 degrees. That's why it glows that sharp, bluish-white. Then there is Sirius B, a white dwarf, physically about the size of Earth, but containing nearly a full solar mass of matter crushed into that tiny volume. A single teaspoon of it would weigh as much as an elephant. Its surface temperature sits around 25,000 degrees, radiating mostly in ultraviolet light the human eye cannot see, making it the closest white dwarf to our planet. The 2 orbit each other once every 50 years on an elongated ellipse, swinging from about 31 astronomical units apart to as close as 8. Decades of searching, using Hubble, the Very Large Telescope, Keck, and others, have turned up no confirmed planet in this system. The likely reason is that Sirius B, before becoming a white dwarf, was once the heavier of the 2 stars. About 120 million years ago, it swelled into a red giant, blasted its outer layers into space, and collapsed into the ember we see today. Any planet that had begun forming in that system would have been scorched or thrown out entirely. And roughly 660 million years from now, Sirius A will go through the same transformation. One enormous, blinding flare, and then silence. Sirius disappears from our sky forever. 14 light-years out, things go quiet. A small, dim red dwarf called Wolf 1061 produces barely 0.1% of the sun's light output. You will never spot it with the naked eye. But 3 rocky planets orbit it, and each one tells a completely different story. The innermost, Wolf 1061b, completes a full year in just 5 Earth days. One face likely bakes in permanent direct starlight while the other freezes in permanent darkness. Whatever atmosphere it once carried was stripped away long ago by stellar wind and radiation. Then there is Wolf 1061c, a planet that spent several years near the very top of every astronomer's list of the most promising rocky worlds ever discovered. Rocky, super-Earth-sized, at least 3 times our planet's mass, and sitting inside the habitable zone when it was first described in 2015. Headlines were excited. Scientists stayed cautious. By 2017, a closer look at the star's actual energy output moved Wolf 1061c to the hot inner edge of the habitable zone. One scientist used the words suspiciously like a runaway greenhouse in a published paper. The orbital path wobbles in ways that could swing the planet's climate from frozen to boiling and back again far more violently than anything Earth experiences. Liquid water, there is not impossible. Under very specific atmospheric conditions at the right moment in its orbit, in a sheltered region. Nobody is ruling it out. Nobody is confident either. The third planet, Wolf 1061d, follows a stretched oval orbit and sits far too cold for surface water. Scientifically valuable for what it tells us about how planetary systems around red dwarf stars evolve. Practically speaking, uninhabitable. 27 light-years out, down in the southern constellation Columba, a young red dwarf called AP Columbi is doing something that interests scientists for a very specific reason. It's still a child. Somewhere between 130 and 200 million years old, compared to our sun's 4.6 billion. It's still contracting, still settling into itself. And it shows. Its brightness can leap by a factor of 10 within minutes during solar flares. Anything orbiting close enough to receive warmth would be getting hammered by radiation, ultraviolet spikes, and charged particles capable of stripping away any nascent atmosphere before it ever had a chance to stabilize. No massive planets have been found within 4.5 astronomical units. Theory says that's expected. The system is probably too young for fully formed planets to exist yet. That is exactly why AP Columbi matters. It gives us a rare, close-up view of what stellar youth actually looks like. What a young planetary system has to survive in the first few 100 million years of its existence before conditions calm down enough for worlds to take hold. It's not a destination. It's a window into a past that every planet in our solar system, including Earth, once lived through. One additional detail, AP Columbi wasn't born where it is now. Its path through the galaxy traces back to a star cluster 450 light-years away. A supernova likely kicked it out of its birthplace. It has been coasting toward our neighborhood ever since. A runaway, carrying its youth across the void. 51 light-years away, in Gemini, Castor sits as a single point of light to the naked eye. A small telescope splits it into 2 stars. Push harder, and each of those 2 resolves into a pair, stars orbiting each other too closely to separate visually, but unmistakable in their spectra. Further out still, a third pair orbits the entire arrangement from a great distance. 6 stars. One gravitationally bound system. The 2 dominant stars sit about 10 billion miles apart, orbiting each other on a 445-year loop. Each carries a small red dwarf companion in a tight inner orbit. The outermost pair, 2 red dwarfs so close together they complete one orbit in under 20 hours, eclipse each other every single time they go around. No confirmed planet exists anywhere in Castor, though a candidate object detected in 2018 remains under investigation. Standing on a rocky world deep inside that system, if one existed, the sky overhead would be unlike anything in our catalog. 2 dim red suns completing a full circuit in less than a day. Off in another direction, 2 blazing blue-white stars burning brighter than a full moon. No true darkness anywhere, just a slow, endless, shifting glow. Every star we have visited, Barnard's, Sirius, Wolf 1061, AP Columbi, Castor, sits inside the same enormous structure. The local bubble, a cavity roughly 300 light-years across, carved out by a chain of supernova explosions 10 to 15 million years ago. Those dying stars swept the surrounding gas outward, leaving behind a hollow filled with plasma at nearly 1 million degrees. It glows in X-rays. The only thing standing between you and that radiation right now are the sun's magnetic field, Earth's magnetic field, and the column of atmosphere above your head. Remove any one of those three, and life on the surface looks entirely different. Inside the local bubble, the solar system drifts through a smaller pocket called the local interstellar cloud, about 30 light-years wide. We are approaching its far edge. In roughly 2,000 years, the sun exits it. Scientists have pulled iron-60, a radioactive isotope that only forms inside supernova explosions, from Antarctic ice cores. That iron came from a dying star somewhere nearby. Its ashes ended up frozen at the bottom of this planet. The space between stars is not empty. It has weather. It has memory. It carries the remnants of things that died before Earth existed. Zoom all the way out. The local bubble sits inside the Milky Way. The Milky Way sits inside a cluster of galaxies. That cluster runs along one filament of a cosmic web stretching billions of light-years across. Inside that web, along one filament, in one galaxy, on one arm of that galaxy, inside one bubble of hot plasma, inside one cloud of thin hydrogen, orbiting one ordinary star, is this planet. And on this planet, a species that has only been detecting worlds around other stars for about 30 years has already confirmed over 6,000 of them. The first confirmed planet around a sun-like star wasn't found until 1995. The count is now past 6,000, and it's still climbing. The instruments being built and launched right now are the ones that could, for the first time, detect something like a true Earth twin, another ocean world, another atmosphere, another pale dot circling a distant star. Nobody alive today has seen that. Not yet. Every version of the map we have drawn has been better than the one before it. The next version is already being drawn. And what we know in 2026 will almost certainly sound incomplete, perhaps even naive, by 2046. That is not a failure. That is exactly how this works.